Hello, this is Ms. DB. In this video, we are going to review some exponent properties involving quotients. And the two we're going to look at today is the quotient rule with the same base. For example, a to the nth over a to the mth equals a to the n minus m. So the rule is that you subtract the exponents, and the quotient rule with the same exponent, when you have something like a fraction raised to a power, then you can apply that power to both of the numerator and the denominator. So a to the nth over b to the nth. And there's some examples with numbers too, like 2 to the 5th over 2 to the 3rd. You can, because they're the same base, they both have a base of 2, you can subtract their exponents, and that would be 2 to the 5 minus 3, but 5 minus 3 is 2, so you could write that as 2 squared, which is 4. Or here's a number example of the other one, 5 over 2, so you have a fraction 5 over 2 raised to the 3rd power. You could write that as 5 to the 3rd over 2 to the 3rd. And then you could evaluate 5 to the 3rd, because that means 5 times 5 times 5, and that would be 125 over 2 times 2 times 2, or 2 to the 3rd power is 8. So 125 over 8, you could write that if you had to evaluate it. So we're going to use those two rules or properties to simplify some of these problems on this worksheet. The ones that are highlighted are solved in the Khan Academy video, so I'm going to leave those for you to look at the other video about, and we will do a few more of the problems. If you cannot see all of these problems correctly on your version of Word, then you can open up the PDF worksheet, which will preserve the formatting no matter how your Word version looks. So you can open up the PDF version to see exactly how they should be. We're going to look at number 5 because this one looks a little complex. And you can type your answers. In fact, at the top, I showed how you would write this if you were typing first with the backslash key for the fraction bar. Or you can insert an equation, which is what I did on these ones over here. Or, of course, if you printed this, or if you're working on your own paper, then you can write with pencil or pen. Or if you have a drawing pad or a touchscreen, then you can write this using a pen tool or whatever your. Whoa. There we go. All right, so I'm going to use my drawing pad, and I'm going to use the property that says that if you have a fraction raised to a power, then that's the same as the numerator raised to that power over the denominator raised to that power. But my numerator is a power, 2 to the 2nd, so I'm using parentheses to show that that's all being raised to the 3rd power, and in the denominator I have a power, 3 to the 3rd power, and that's being raised to the 3rd power. So now we're going to be going back and using the rules from the previous assignment on when you have exponents with products. This one was when you raise a power to a power, you multiply the exponents. So the base stays the same of 2, and then you multiply the exponents of 2 times 3, and you would get 6. And in the denominator, it's the same rule. We leave our base the same. It was 3, and then you multiply the exponents, and 3 times 3 is 9. This is how you would leave this. You wouldn't be able to simplify anymore because you have different bases. One is 2, one is 3. And because the exponents are large, we're not going to evaluate what that would be. 3 to the 9th power is a very big number. 3 to the 9th. And we're not going to write this out. And so this would be your answer at that point. We're just simplifying. And you can write your answers with exponents. All right, let's look at some of these next ones. Number 9 is in the Khan Academy video. Let's look at number 12. 12 says 25x times y to the 6th over 20 y to the 5th times x to the 2nd. The 25 over 20 is something that I'm going to simplify on its own without the x's and the y's and so on. Now I'm going to write the x parts next to each other. So I had an x on the numerator in the top part, and on the bottom I have x squared. So I'm going to put that together. So it's x over x squared. And then I'm going to do the y part. So on the numerator, I have y to the 6th. In the denominator, I have y to the 5th. And you can write this all with one bar, or you can do it as 3 separate ones. It doesn't matter. So now I'm going to look at this part here. X over x squared. X over x squared is the same as x over x times x because x squared means x times x. I could cancel this x with this x, and I would be left with one x in the denominator, so I would need a 1 on top. So one way I could write this is as an x in the denominator. And there could be a 1 in the top, or you can just wait and fill in with the other stuff that'll be on top. The other way you could write this is you could put your missing exponent of 1 on there, and you could say the rule is that when you're dividing the same base, you subtract their exponents. So you would take 1 minus 2, and that would be x to the negative 1 in the numerator. So if you were told to write all of your terms in the numerator, you would write it as x to the negative 1. If you're told to have positive exponents, then you would have 1 over x, or 1 over x to the 1 if you prefer. All right, let's look at another part. Let's look at the y's. Okay, here's the y parts. We have y to the 6th over y to the 5th. I could do something similar as I did over here. I could write this as what it means. It just takes a while. I have y times y times y times y times 6 of them on the top, and y times y times y times y times y on the bottom, and I could cross off, cancel the ones that are the same on the top and the bottom, and I would see I'm just left with one y on the top. Or I can use the rule that says when you have the same base, y and y, you subtract the exponents. So that would be y to the 6 minus 5, and that's y to the 1, and that will be in the numerator. So far I have y over x. All right, now let's simplify the 25 over 20. This part here. 25 over 20. Well, I know that they're both divisible by 5. I'm just simplifying the fraction. I could divide this one by 5. 25 divided by 5 is 5. And I could divide the bottom one by 5, and that would be 4. So I have a 5 in the numerator and a 4 in the denominator. Well, it doesn't make much sense to do 5 times 1 times y. I can just write that as 5y. On the bottom, I have 4 times x, or 4x, and this is as simple as it can get. So my final answer would be 5y over 4x. Now, that one was in the Khan Academy video. I didn't mean to do that one again, but I guess we have it done twice now. And the one that I was going to do is number 14, so I'll go ahead and work on that one as well. Number 14 says we have 6a squared over 4b to the 4th, all to the 2nd power, times 5b over 3a. So we need to simplify this part first, and then we'll worry about the rest. So this part, we'll use the property that says if you have a fraction raised to a power, that means you have everything in the numerator raised to that power, and everything in the denominator raised to that power. And then I'm going to write this part down next to it so I don't forget about it, 5b over 3a. All right, let's simplify 6a squared to the 2nd power. So I have to take the 6 to the 2nd power because that's one of the factors of this. And I have to take a to the 2nd power to the 2nd power. In the denominator, I have to take the 4 to the 2nd power. And I have to take b to the 4th to the 2nd power. And then again, this is still 5b over 3a that I'm multiplying by this. Okay, so we're getting closer to being simplified, but there's still a couple more steps. 6 squared is 36, 6 times 6. And a to the 2nd power to the 2nd power, the rule is when you raise a power to a power, you multiply their exponents. And that would be over 4 squared, which is 16, and then I have b to the 4th to the 2nd power. So again, multiply the exponents. 4 times 2 is 8. And now I have to multiply that by 5b over 3a. So I need to put the like parts together like I did in number 12. So the 36 over 16 is already, the number parts, the coefficients are already together. I have to simplify that still. They're both divisible by 2 at least. I'm going to put the a's so that they're over top of each other. A to the 4th over this. Oh, wait, I'm going to go back. Because there is some more coefficients that I should put. The 5 over 3. I'm going to write that next to the 36 and the 16. So there's the 5 and there's the 3. 5 in the numerator, the 3 in the denominator. Okay, now I'll do the a's. A to the 4th over a, or a to the 1. And then I'm going to put the b's. There's 1b, b to the 1 on the top, b to the 8th in the denominator. All right, now we can multiply 36 times 5 and 16 times 3 so that we can simplify this. 36 times 5 is 180. 16 times 3 is 48. So that's the coefficient part, the number part. Now we'll do the a's. We have a to the 4th on top, a to the 1 on the bottom. They're the same base, so we can subtract their exponents, and that would be a to the 3rd on the top because there's more a's on top. Now look at b to the 1 over b to the 8th. If you wrote it out, it would be 1b on top and a whole bunch of b's on the bottom. In fact, there's 8 of them on the bottom and 1 on the top. So 1 minus 8 is negative 7, or that's the same as 7 b's left in the denominator, so b to the 7th power. So we're almost done with this. All we have to do is simplify the number part, the 180 over 48. Let's see. They're both divisible by 2, of course, but probably by more than that. Let's see if 180 is divisible by 12, because I know 48 is. It is. So if I take both of them divided by 12, 180 divided by 12 is 15. 48 divided by 12 is 4. And then we have a to the 3rd in the numerator with the 15, and b to the 7th in the denominator with the 4. So these are not fast. They're kind of like puzzles, and you just keep working step by step by step until you have it as simple as you can get it. And then you know you're done. When you do number 15, it says to simplify first. It's much easier if you simplify this first before plugging in a is 2, b is 1, and c is 3. So by simplify first, you're going to, on the top, you will multiply the number parts together. We could rewrite this as 2 times 6 times, and then put the a parts together. So that would be a to the 2nd times a to the 1. If there's no exponent, you can put a 1. And then put the b parts together. That would be b to the 1 times b to the 1. And then the c parts together would be c to the 2nd, c to the 3rd. And then all over 4ab squared c. So once you simplify the top, you can then simplify with what's in the denominator and then do this at the end to plug in a is 2, b is 1, c is 3. Once it's simplified, there will only be one of the a's, one of the b's, and one of the c's. There might be exponents on each one, but you won't have them all over the place like you do now. So it'll be less work at the end if you simplify first. All right, if you have any problems with this assignment, please visit me during my office or ASC hours, and we'll work on it together. Thanks very much. Have a wonderful day.